Hey guys, so sorry I have been out past couple days. I will return though tomorrow. So what I want to do is just get you prepared for the worksheet you're going to have today. We're starting a new topic, and that topic is forces, and you should be taking notes as we go through this or both screencasts, depending on how quickly I can get this done. So forces, the unit may also be called Newton's laws. So what we're going to do is define force, talk about, we're not going to talk about any Newton's laws today specifically, even though we will be using them, or some of them. So in its most basic function, a force, all you need to know about it is that it is nothing more than what we're used to as a push or a pull. If you push somebody, they feel it. If you pull somebody, you feel it. Or if somebody pulls you, you feel it. A force is something you feel, something that is perceivable. You know when somebody's pushing on you. You know when you hit something because there's a force that's being applied to you. We do say, along with that, that force is being applied. So, a force has a very simple equation. I know a lot of you watch Big Bang Theory, watch whatever, have come across this equation many times where the equation, pretty simple, is m times a. What they say, force is mass times acceleration. What this really should say is that net force equals mass times acceleration. So that begs the question of what is net force. And by the way, sometimes this is written as acceleration is net force divided by mass. So, first of all, let's figure out the units here of what force is. So the units, we'll leave force for a second. So the units of mass is kilograms, and the units of acceleration are meters per second squared. So what does that tell you? That tells you that a force unit would be a kilogram meter per second squared, and you're like, Recore, what is that? Well, we simplify it. Physicists are lazy, so one of the big guys that dealt with forces, give you a little hint, tree, apple, he's sitting down, even though he was actually in his kitchen. Apple falls. Who's this guy? Hint, I-N. Give you a little bit of time. And it's a Newton. So the unit of force, abbreviated capital N, it has to be capital. So the unit of force is a Newton, where 1 Newton equals a 1 kilogram object accelerating at 1 meter per second squared. So 1 Newton force would accelerate a 1 kilogram object by 1 meter per second squared. Force also needs direction. It needs direction because it depends if I push something this way versus if I pull something that way, I need to be able to distinguish between those two forces. One is east, one is west. You've got to pay attention to that. It makes a huge difference when we're dealing with net force, and that's what we're going to talk about right now. So, net force, what is it? All it is the sum of all forces acting on an object. So, let's just make a little scenario here. We've got a box, and it is being pulled to the right with, let's say, 5 newtons of force by one person, and another person, playing a little tug of war here, is pulling with 4 newtons. They're not as strong. So the net force, sum of all the forces, well, force requires direction. So we have force 1 of plus 5 newtons. We've got force 2 of minus 4 newtons because it's opposite direction. So that would be to the left. Left is always negative. So our net force, which is F1 plus F2 plus however many forces there are, we can go up to F100. It doesn't matter how many forces there are. In this case, we only have the 2. So my net force is 5 newtons plus negative 4 newtons. So my result is plus 1 newton, or I could say that as 1 newton to the right. Thought you were done with those directions, but you were wrong. So what do we do with this? Let's do one more quick example. Let's say that 4 newtons now came over here. So you have both forces. You got the 5 newton and you've got the 4 newton. And if you notice, I made this arrow just a little bit smaller because the 4 newton should be smaller. So we'll talk about this more when I return, but a key thing to know is that force is a vector. We haven't talked about what vectors are, but basically, in its most simple form, it requires the magnitude, that would be like the 4 and the 5. Sorry, this pen's not working very well. Magnitude and direction. So, we have the direction. Our net force in this case would be 5 plus 4, really plus 5 plus 4, which would be plus 9 newtons, or 9 newtons to the right. All right, so remember back to that equation that I just said. We had our equation of F net equals mass times acceleration. Well, F net equals mass times acceleration, so a real simple problem might be, for example, and by the way, substitute whoever you are. If there are questions, if this is going too fast, by all means hit pause, give the student a chance to catch up, if you will. Thank you. So, example. Let's say a box has a force of 12 newtons pulling east and 8 newtons pulling west. If the box has a mass of 4 kilograms, what would the acceleration be? A being the acceleration. All right, well, so we have a net force. We've got to draw it. Forces, it really helps to make a drawing because we're going to have different situations where there are 5, 6 different forces acting on the same object. So it really helps to just keep all your numbers straight by putting them into a drawing. So 12 newtons east, that's a force 1. That arrow is pointing to the east, so I don't have to write east here. I could if I wanted to, but I have the arrow that's telling me my direction. And I have 8 newtons pulling west. So, and you get, again, you can see sort of the relative scale. It doesn't have to be perfect. So my net force, the first thing I want to identify, is F1, this would be F2. F1 plus F2, which is 12 plus negative 8, so positive 4 newtons, 4 newtons to the east. I have a mass of 4 kilograms, so my acceleration is what I'm looking for. Acceleration is net force divided by mass, and I get plus 4 over 4. So remember that a newton is it's a short way to write a long unit. Remember that it was kilogram meter per second squared. So kilogram meter per second squared divided by 4 kilograms. Kilograms cancel. We get the right units, so you don't have to worry about that. And we get plus 1 meter per second squared. Remember that acceleration needs direction too. So we need this plus still. Or we can say 1 meter per second squared to the right, or to the east in this case, because we said east. So either way, we can get a nice, simple mathematical expression. All right, and the last thing, we'll be able to do this in one screencast, which is awesome. All right, so last thing that'll get you through the worksheet. Sometimes you might only have one force, so that's a little easier. That one force would be your net force, because you would have a net force equal to just F1 plus F2 plus whatever. But if you only have the one force, then your net force is that one force, because that plus 1, plus 2, whatever would all go away. So, last thing that we need to talk about is the difference between mass and weight. There's a huge difference. We kind of use them interchangeably in everyday life, but there's a big difference. And there's a really simple way, very closely related to what we're talking about, forces, to determine if you know one, you know the other. And that's because our weight comes from gravity. How that works is the Earth is pulling us down. Remember, force is a push or a pull. So it's pulling us down. So the gravity is a force, and it's causing that acceleration, because force, net force, is mass times acceleration. But our acceleration on Earth, if we're falling or working down, is 9.8, or negative 9.81 meters per second squared. So, weight, which has its own symbol, we call it the force due to gravity, so F sub g. Some textbooks you might see just capital W, but we're going to use F sub g, is equal to the object's mass, which is just how much stuff it has, how much material makes it up, times the acceleration due to gravity. So we're, again, g is negative 9.8. And that negative 9.81 is because of this down arrow. Gravity's always pulling with a force downward. So if you know the weight, you know the mass. So let's do an example here. A 400 Newton ball has a mass of ... So 400 Newton ball. Newton tells us that that is the force, that is the weight, that is our Fg. So, and really it should be negative because it's going down, so negative 400 newtons, because the pull of gravity is down. You still need to pay attention to those directions. Otherwise you'll get a negative mass, and that doesn't make sense. Our acceleration is negative 9.81 meters per second squared, and we're looking for our mass. Just solving that equation real simply, Fg over g, so negative 400 over negative 9.81. I don't have a calculator with me, but it's going to be something, the negatives will cancel as you'll see. Then it'll be something along the lines of 40.8 maybe kilograms. Something along those lines. Kilograms is the unit of mass, so that's exactly what we expect. So sometimes if you don't have the mass, it might say something like this to start with. A 400 Newton ball, a 20 Newton kid, whatever the case is. So if you have that information, that's the weight, and that allows you to get the mass. So you should be good to do your worksheet. Please work hard, and if you don't finish for homework. And I will check that when I return tomorrow. All right, miss you guys. Hope you have a great day, and I will see you soon. Bye.